So tonight I'll be talking about deploying ML models in Azure ML with a Power BI integration. So I'll be walking through the end-to-end flow and how I usually tackle problems like these. But before I start, I just wanted to give a brief introduction about myself. As Mark had said, I'm currently Principal AI and Data Science Consultant at DesignMind. Previously, I started my career at Microsoft on the core data science team. And then I went to be the lead data scientist at an early stage tech startup in New York. Following that, I was the first employee and head of operations at also an even earlier stage company in Miami. And so while I was at Microsoft, I also co founded its global women data science community. And I'm the first author for two applied ML patents and a publication in natural language processing applied to A/B experimentation. And I hold my degree in math and CS from Carnegie Mellon. So I want to start out with George Box's quote, just to always keep in mind is that all models are wrong, but some are useful. And so the agenda today, we have a good amount of ground to cover, as I was saying. I just want to give a brief introduction to Azure ML and Power BI for those who don't are not the most familiar with it, and then we'll talk about the overall process and go through that entire pipeline and end with best practices and tips and Q&A. And again, feel free to ask me questions as we go on throughout the slide. So won't spend too much time on this, but just want to give a brief introduction on the power of leveraging Azure ML and Power BI together. Really, the integration of those two allow for this seamless use of ML predictions, and we're able to really surface those end results to clients in order to track either model performance over time, feature importance, and also interpretation of those results. So this is just like a brief overview of some Azure ML benefits over its competitors. What I really like is the end-to-end ML ops portion where it's really providing tools for the entire ML lifecycle. Its interoperability is great, and this scalability is great as well. So zooming out first, want to first talk about this data science lifecycle. And so when we first start is really in this point of business understanding. So this part is really looking at translating that business question or engineering question into a solvable data science question. Today, we'll be focusing more on the step 3 on the deployment part. So I'll be going over briefly business understanding, what questions to ask during the first during each part, but the main focus of today's talk will be on the deployment portion. So diving right in for the business understanding, the first step here is to really understand like what are the key variables that serve as the model targets and really identifying what you currently have. So understanding what relevant data sources your business has access to or does not and needs to obtain. So this part is where we want to really spend the most time in working with stakeholders and clients in really taking that business or engineering problem and translating it into a solvable data science problem. So assessing what's given and really building that bridge to what we want to achieve. So we want to define objectives. We want to work with customers and other stakeholders to really understand, identify what that problem is. And also you want to identify what those data sources are in order to help us understand how to obtain those success metrics. The data acquisition and understanding would be next, and to understand like how are we supposed to develop a solution architecture that refreshes and is able to score the data set that's going to underlie that's going to be the input to any ML model. So we need to make sure that we have these like clean, high quality data sets where we really understand each column and understand what the relationship of the columns are relative to each other. And so this part is really just like ingesting the data, exploring it, and also keeping in mind that if this proof of concept does become successful, really like how do you go through this process to ensure that you can really productionalize this at scale. So some questions that I typically ask myself during this phase is like, what data sources do I have available, and do I need more to accomplish my goals? How do I really account for measure bias? And how will that bias influence how I interpret my results? What assumptions am I making? And do I really have an understanding of the underlying nature of the data? In this case, at this step, I really like to work with the engineers on with the data engineers and the engineering teams who really are consuming and who really are defining the data that I'll be consuming. The next part is the modeling part, and this is the part that every data scientist, ML researcher focuses like most on, is really determining is really determining like what is the optimal algorithm and tools to apply here in order to achieve your goal. And so I'll be going through a live demo of this with the data set that I will run through in a bit. But at this portion, we really want to ask ourselves question like, do I understand and handle class imbalance in my feature set? Do I have a process for accounting for sparsity and missing values as well as null values? Um, and so on and so forth. So now really the focus for today is on the deployment process. So the data preparation, and then we want to do model training in Azure ML, and we want to do deployment, and then take that and integrate it with Power BI. So there's 5 different ways that I found in Azure ML Studio to really do the model training. Personally, I personally use the notebook as well as the Azure ML SDK, but it really depends on the use case as well as who the user is. I typically like to use their notebook views because it just allows me to write like PySpark, Python, R, and to really customize and be able to debug the models that I train. I'm going to pause here if there's any questions. Okay. So the data set that we're working with today is a publicly available data set on global climate. And so this is looking at information about sustainable energy for various countries across the year. So this is a data set that goes from 2000 to 2020. And the target column that we want to build out a predictive model around is renewable electricity generating capacity per capita. So the goal here is that we want to build this binary classification model to predict if this renewable electricity generating capacity per capita for the countries will increase or decrease in the next year. And so I put a link in the appendix. I'll share this deck out after the talk to all of the different publicly available data sources that I personally like to look at and play around with. But this is just an example of what this table looks like. And so we have the entity, which is the country, access to the percent of the population with access to electricity, access to clean fuels for cooking, all of that. And you see that the target column we care about, the renewable electricity generating capacity per capita, that's a mouthful, is a continuous variable. So what we want to do is that we actually want to do a little bit of feature engineering on top of that to take that continuous variable and make it binary in order for us to build this model to predict whether or not it will increase, which we're going to encode as 1, or decrease, which we're going to encode as 0 in the subsequent year. And so this is just like looking at the trend of what of the target variable, and for the top country. So we want to make sure that before we do any of the modeling, we want to do exploratory data analysis, or EDA, before anything, and understand like the top level insights to get a general idea of what exactly is the data story that's being told here. I like to call this step the FYI of what is going on. So If we just look at histogram distributions, what we see is that most countries have high access to electricity. And so we see that the noticeable number of countries with lower access really indicates that there's a disparity in electricity globally, in electricity access globally. We see this like bimodal distribution for access to clean fuels for cooking, which tells us that like while many countries do have this, there are then on the other end, several countries have very limited access. The financial flows to developing countries from the US, this is a right skewed, which means that most countries receive lower financial flows with a few exceptions or outliers that receive significantly higher amounts. Um, and then the other ones are really looking at renewable energy share in terms of the total energy consumption as a percentage. And we see that this is pretty widespread, with low, several countries having just like low renewable energy shares, while others having higher percentages. The GDP per capita is another feature column in here. It's right skewed, and as expected, most countries have a much lower GDP per capita, with a few outliers that have significantly higher ones. So continuing more with exploratory data analysis and pulling out these more top level insights, so we just do a correlation heat map of just the key features we're pulling out. So we see that the access to electricity, the percent of population that has that, has a positive correlation with access to clean fuels for cooking. This is not a surprise to us. It's really just indicating that countries with better electrical infrastructure might also have better access to clean cooking fuels. The GDP per capita is also positively correlated with both access to electricity and also access to clean fuels for cooking. Again, not surprising. Countries with higher GDP tend to just have better infrastructure. And we see that the percent of the renewable energy share in total energy consumption doesn't really have any strong correlation with any of the key features that we see. Any questions here?
None have been posted so far in chat.
So now we want to define the target in terms of what we want to predict on. We want to predict on looking at the trend of renewable energy generating capacity per capita. So pulling this out here, we see that for the US, there's a notable increase in this capacity starting from the 2000s. After the 2000s, China really shows this sharp increase in renewable electricity generated per capita. India shows a gradual increase visible from the late 2000s. Germany has seen a consistent increase since the early 1990s, and Brazil has seen a relatively stable trend until the 2000s. And then after the 2000s, we see that there's a gradual increase here. So now we want to prepare the data for our binary classifiers. So first we want to encode and create this label class or this target class. So like I was saying, we want to predict with this model if the renewable electricity generating capacity per capita will increase or decrease in the next year. 1 for increase and 0 for decrease. And how we're encoding that is we'll be computing the diff for each country for this target variable for this year and the next year. We'll do feature engineering to account for the time series data that we're working with here. And then we want to split the data into training and test. So everything up to 2018 will be training, and 2019 up until the latest, which I believe is 2020, will be testing. And then lastly, while we're doing the feature engineering, we want to ensure that we do a feature scaling. So we're comparing apples to apples and standardize and normalize all of the features that we have here. So I like to use the notebooks view in terms of my overall ML ops deployment pipeline. I think it's very flexible, it's configurable, and I'm also able to audit, to debug. And so really the overall process for how to do it with notebooks in Azure ML. I've worked with AWS and GCP, and I found the process is overall the same. I do all of the data preparation and model training in the notebook. So typically, I have the training set be continuously uploaded to an Azure Blob storage location. And then what's outputted is this serialized model. And we put that back into Azure Blob storage. And then we want to deploy the trained model as a web service. And so the output from that will just be an API key and REST endpoint URL. Then you can just call and make predictions on. And the connection to Power BI is really just the output from that and the endpoint of the URL of the deployed web service. And then in Power BI, we can make as many visualizations as we want. Any questions there before I move on to the demo?
Unposted.
Great. So this is an example. I'll just be running through what I had just discussed in the deck itself. So we want to configure our workspace. This is the climate data that I was working with in the rawest form. And so this is generating the visualizations and the exploratory data analysis. And this is really now going into the feature engineering portion. So we want to create this lagged feature in order to account for the time series. And we want to be careful of NA values, null values, missing values, the blanks. So right here, we're defining our target column. So we're looking at defining it so that it's based on that diff. So that 1 or 0 is our binary target, is looking at 1 is that this target, this capacity for renewable energy increases in the next year, and 0 otherwise. And we see that the distribution of the label class is pretty even. And so that's a great sign. So we see it's pretty evenly spread. And now we want to split the data based on the year. And so, like I was saying, everything that was below 2018 is a train. Everything that is after will be the test. And we're just going through, and this is applying the, so we want to normalize all of the features as well before we input it into any ML algorithm. So after normalization, we over here, we're doing some imputation of missing values, but overall we have chosen to just like drop the features with a large number of missing values. There wasn't as many, so we're able to do that. Otherwise, we would want to impute. So typically it's best to use the median to impute, but the mean is most straightforward here. So we're just going to impute the mean from the distributions of the columns and use that to fill in missing data. So we see afterwards that we don't get any more missing data. The initial model that we're fitting on top of that is random forest, since overall it performs well, just regardless of it performs well, taking into account outliers and different distribution of the underlying data shape. And so we see that it's not doing great. So it's 58%. We see the confusion matrix here. But we do see that the true positives and true negatives. So the precision, recall, and F1 score, overall, the random forest, we probably want to try other models. And so I throw at it logistic regression, SVM, k-nearest neighbors, and XGBoost. And so when we do that, we see that support vector machine performs the best out of here. And so typically after this, if this were a real scenario, what we would do is we want to increase this accuracy while maintaining bias, while keeping in mind bias variance trade-off, because we don't want to overfit our trained model on the set. And so typically after this, like, we could try ensemble methods, which basically just means putting a lot of these different models together, and or we can also try hyperparameter tuning. And so in this case, I just took the model that performed the best, since we're focused on the deployment portion, and not the training for this. And so we see that the best one is the support vector machine with a 64% accuracy. So from here, what we want to do is we want to serialize that model, and then we want to register that in Azure ML. And so if we go to our machine learning studio, um, we see that this is a registered model in here. We go in here. So once we have that registered, we are ready to deploy this model as a web service. And so over here, I'm just writing the file score py. So this file is needed in order to deploy your model. And so we configure this, and then the service variable here is what we end up um, deploying as a web service. And so you can see the deployment can be up to 20 minutes. And so this deployment actually failed, so I have to go back and debug that. But after assuming the deployment succeeds, what we do is that we end up with this endpoint URL, and we end up with a key. And so what we see here is that this is an endpoint that we deployed. And so what we see here is that this should be having, if it were to be successful, this should be having a URL here. And then going back here, and then we get a key if authentication is enabled. So we take these two outputs and we go into Power BI. And so right here is that we get the web service URL and key. And so that's the code showing like how we're able to get that URL and authentication key. And then we want to get data from the web service. And so what we would do is straightforward, and we would just go into Power BI and we would go to get data and then go into web and take that URL and put it in here. And that's how you would connect your deployed endpoint. And so some of the things to keep in mind is that since Azure ML is expecting a post request, you might need to configure Power BI's advanced data input options. After that's loaded, we want to also just like transform and load that data so that we can put in test data sets and see how that model will perform. So the best practices and tips here is really that we need to be really careful about the subscription IDs, API keys, connection strings. What I have configured in the Azure ML environment is really looking at putting everything in a config.json file. And so that should hold all of your keys and should really be getting all of your data from there, all of your subscription keys and sensitive information. So the other part is that we need to be careful of just monitoring all of the deployed models themselves. And so the best practice is really to have someone be on point, whether it's the ML ops engineer or the data scientist, but really need to be able to regularly monitor the performance and usage of the deployed models. And lastly, we want to really ensure this data consistency and quality. And so all of this is a connected pipeline. So we really want to be able to trace back both having the data flow from its initial point to all of the different input and outputs that we're discussing. So really being able to have that CI CD environment and be back and go back and be able to debug any inconsistencies or any data quality issues. And so typically I have multiple notebooks and break it down into pre-processing and cleaning notebook, and I will have them call each other. And we want to just also make sure that we leverage the version control portion of using notebooks as well, just to track changes and maintain a consistent data processing pipeline.
So we've got some questions that have been posted so far, and then I know you're about ready to transition. Also, Connie, apologize for the timing of jumping in here. Will is asking, does Azure ML Studio support Scala?
It does support it, yes. Yes.
Okay. And also from Will, how does Azure ML differ from Databricks? Is Azure ML using Spark under the hood also?
It is. So the notebook here is in PySpark. And so you can actually pick, but I haven't I've worked with Databricks as well in the ML flow, but I've personally found it really depends on what I guess it really depends on like what the project is and what the goal is. I found the Azure ML Studio environment to be more interoperable and more easily connected. And so you can really build that overall pipeline to deploy. And typically I would write ML models to deploy as an endpoint. So any backend developer can call that or hit that in any web application.
Okay, and thank you. And then Doug is asking also, would you know if ML Studio is cheaper to run than Databricks? Any
I'm
ideas on
not
cost
sure.
comparison?
That part I'm not sure. I would defer to Mark. I'm not sure on that one.
Okay, so I'll duck that because there are multiple marks on this call. But but then also Michael is asking, I would like to use Azure for a high-spec GPU deployment to cope with a 1 gigabyte 3D image input.
Mhm.
What is the best Azure service um, to use for it?
Um, Sorry, could you repeat the question? It's
Yeah, it's what specific Azure service is. Okay, so he corrected it here, or tried to correct it, and I might not be inserting it right. But he wants to use Azure for high spec GPU deployment to deal with a 1 gigabyte 3D image input. What specific Azure service uh, would he use for that? And
that
Michael, maybe you could
yeah.
come off mute if you want, Michael, and clarify that, or in the chat, either one. And maybe while you do that, I can jump ahead to the next question, which is from Kia. He said, "Sorry, I got a bit lost. What data were you bringing into Power BI?"
Oh, yes. So the data that's being brought into Power BI would just be the predicted model. So I wanted to do this live, but it crashed on me. So I'll make a recording of this and make sure to share it out afterwards. But I wanted to show essentially a new Dataset, and then we would use the API endpoint to predict on that. I had created a Flask application before too to surface that better, but have a better UI for that. Okay, so I'm gonna send that out just afterwards and make a screen recording of it. But what I wanted to show in Power BI is essentially what I was showing as a Flask application is like having that UI layered on top to look at if we input the prediction for the next year for the model, what those results would be. And so like if we were to input, if we were to look at like, is the US consumption, is the US renewable energy capacity per capita going to increase in the next year or not? And so I wanted to do that for just like show the various countries and then show the model prediction and then also output the probability of how well that model did in terms of predicting every single input, because what I had done before is that anytime I've deployed ML models as these API endpoints, I really like to have it run in a dev environment and have like new, never before seen data input be used, and then look at how well that trained model does on this new output. And then we would really, that's more of a manual process, because then we assess like what that probability threshold is. And so is like maybe 80% confident that the model says yes, like the US capacity will likely increase. Is that good enough? Or is it, or we have to raise that probability threshold to maybe like 90%. So that's what I wanted to show in Power BI, but last minute it crashed on me, and so I will make a screen recording to forward out to the group afterwards. But I also wanted to show feature importance as well, because the other part is like once we train these black box models, there's another component of Azure ML that's called Interpret ML. And so one of the things I wanted to do is leverage Interpret ML in the notebook and show the results of how do we interpret the black box models that we have trained here. Because all of the models that we're training here is pretty much black box. We get an accuracy or performance assessment, but we really don't understand, like what features led to this, what are the important features that are driving the prediction to go 1 or 0. And so that was the other aspect, is I want to show the feature importance as well as the interpret ML portion on top of the trained black box models.
Thank you for
Oh,
clarification. That was very useful. Thank you.
yes, thank you. And Michael clarified his question, or he rephrased it a little bit. He said, in general, I would be interested to know what deployment services scale best for large data throughput.
That one, I'm not sure. I would definitely say I I'm not sure. I would defer to someone who is more of an ML ops engineer for that one, but personally I'm not sure.
Okay. Thank you. And any other questions that you have? I don't know if you were about ready to jump into Q&A, or if you had some something else you were going to cover next. Connie, I apologize that I jumped in right at that very moment.
Oh, no worries. That's perfect timing. I was jumping to Q&A, and I also just wanted to send out resources as well for public data sets that I've worked with in the past. And so these are just all great. If people want to just like play around with the I'll send out a screen recording of what I wanted to show with Interpret ML leveraged on top of the trained model. I think that was an open source project that a few colleagues of mine from Microsoft collaborated with Microsoft Research, and they had developed it. And I think it's awesome work that they've done there. So I wanted to leverage that in here before everything crashed. But I'll do a screen recording of that and show the results in Power BI. And wanted to also share out just the publicly available data sets as well that everybody should definitely check out and play around with. But other than that, ready for Q&A.
Great, thank you so much. And then I see there's a discussion going on in chat around Michael's question. And so I'm wondering if Armando and Will want to come off mic or off mute to respond to that as well.
Hey, yeah. So on the deployment services that would scale for AI models, Microsoft original suggestion for that, as far as I know, is web apps. But web apps, they do have some scalability issues, some limits. I've seen a very popular adoption of Kubernetes, specifically on AKS.
Okay, thank you, Armando. And Will, you were kind of asking a little bit more. I mean, I can read your question here. And
Well,
you
I mean,
can chime in as well.
what intrigued me about Michael's question is that he mentioned he's talking about 3D imaging. So I'm wondering if he's talking about the Azure AI Vision service. Which
Yeah, I can. If you want, I can quickly elaborate again on the question.
Sure.
Can you hear me? Yes.
Yes.
So I have basically, I want to build an AI service in Azure where I upload very large 3D images, like it's medical images. And obviously it's data heavy because the images are quite large, 500 megabyte, for example, is one, and then process them in a Azure service that gives me that guarantees me a certain turnaround time. So let's say my custom AI model can process these in like 30 seconds with a specific GPU. And I was wondering if I can build a workflow sort of where I can pick hardware and choose a service that gives me this turnaround time, that guarantees me this turnaround time.
Okay, with that additional knowledge, is there anything either Connie, Armando, Will, or other attendees might want to add to the info already provided to Michael?
Well, I'm just curious. So Michael, are you saying these images you're uploading with the large files, are they basically are you going to be tagging them? So are you going to be are you trying to use the ML to kind of identify the tags and do categorization and classification?
It's basically two different images, and it builds a registration between the two of them in with an AI model. And the model is quite complex, so I can't use any of the predefined models in Azure because it's my own custom model that I've built in PyTorch. And I want to run my own custom model in PyTorch to build this registration in a certain time limit. That's my basically requirement.
I see. Okay. So I guess you're basically you're looking for kind of like a serverless solution, basically, which will scale based on the resources that you need, right?
Ideally, yeah.
Yeah. Okay.
Yeah. Hard to solutionize it because the scale here can be the scale of compute or scale of demand. It doesn't seem to be scale of demand since you are using it and doesn't have to, correct me if I'm wrong, but if it's not that many concurrent access or concurrent images being uploaded, then you're talking about the scale of compute. And if you're going to scale of compute, you can actually do it straight in Machine Learning Studio. You can, have a cluster running there and do it straight from there if you're doing it manually.
Great, thank you guys. That's very helpful.
Okay, thank you. And Subhash has posted a question too, also in chat. I think Connie, at this point, you could probably see the chat too.
Yep, I can see the chat. Yeah, so the output would be a data set, right? The output would be we are having the trained model, but we want to give it new data for it to predict on. And so what we would do here is that we wanted to take the test set and take the trained model from the training set and then look at generating predicted values onto the test set. And so then we can actually use that test set, since that's already labeled, we can understand how well that trained model did, and we can look at the distribution of the probabilities for every single row. In that case, like every single row is representing a country per year and all of the different renewable energy capacity that it had for that year. So it would be an overall data set and not a single value. And what we want to do is, like, in a real life scenario, what we want to do is that it would be a data set that's like a new input never before seen, not just the test set. And then we would want to take that trained model and then create and generate predictions and create that new label to look at for every single country in the next year. What is the predicted likelihood that capacity will increase or decrease, and then the associated probabilities for each prediction point. And then on top of that, we want to understand, that's just like the prediction results, but we also want to understand the feature engineering on top of that. And we want to understand what features correlated the most to generate that prediction.
Okay, and for those who may not have access to the chat, I should have just read off the question, and I'm going to do that briefly, even though Connie's answered it. Generally, reports and dashboards expect a data set, not a single data value to create chart, etc. In the given example, it seems we'll get only single value from data source, like 0 or 1. What kind of visualization can be created with single data value? And he got his answer from Connie. Thank you. And thank you so much again, Connie, and thanks everyone for taking the time this evening to join in this meeting and discussion. Thank you very much.